Hello everyone, welcome to our Power Pack series day 3. So guys, I'm Diksha Kaushal, your chemistry master teacher, and guys, today we are going to do what? Let's see that, right? So today is the day of organic conversions. I have top 30 organic conversions for you. And I'll pause the video. You have to pause the video, right? And I'll see if you're able to do this or not. Every time, pause the video and tell me how many of these 30 conversions you got right. So, right, let's start with the first one, that is bromoethane to butane. Okay, so firstly, let's write down the structure. 1, 2, bromoethane means this thing, that is CH3, CH2, and from here, converted to butane, that means CH3, CH2, CH3. So that we can clearly see this is by Wood's reaction. You add 2 of this thing in presence of Na and you will have the elimination of -2 of NaBr, and double the amount of this Rr will be formed. So what we have, Rx plus Na. This is 2 amount of this, it will have the formation of Rr. Right, so that is Wood's reaction we use here. Okay, that is the first conversion, and do let me know how many of you got it right. Just mark every one conversion, you get 1 mark. Let's see how many of you get right. Okay, so second is convert 2-chlorobutane, 1, 2, 3, 4. 2-chlorobutane means this thing, to 1, 2, 3, 4, 5, 6. 3, 4 dimethyl. And here, you know what I can see. This also, if I see it like this, if I see this is Cl, right? This is CH3, CH2, CH2. This should be CH3. Okay. So I can see this. Wait a minute. So I can see this here. It is also 2-chlorona. So now here what you will have, and here what you had actually, this is also same. That is Wood's reaction. 2 times of this with sodium will give you the same. Why? I'll tell you why. Because what kind of free radical will be formed? 1, 2, 3. This is CH3 free radical, and this is also another free radical. Like this, it will be connected, and hence you will have the formation of that compound, right? So another example of Wood's reaction, right? Done. Okay, next is, and I'll just add here which reagent, Na, right? Okay, next is aniline to bromobenzene. Aniline to bromobenzene means here you have aniline. Aniline to bromobenzene means firstly you have to convert it. Bromobenzene means here you have to eliminate aniline, and the best way of doing that is firstly convert it into disonium chloride by adding NaNO2 and HCl at 0 to 5 degrees Celsius, that is diazotization. After that you can either use Sandmeyer reaction, that is you can use Cu2Br2 in presence of HBr, or you can also do Gettermann reaction here. You can also use Gettermann reaction, that is copper powder in HBr, both will give you the same answer. Next guys is same, that is aniline to chlorobenzene. So you know what I'll do here, I am pretty smart in this way. So what I'll do, this is chlorobenzene, so I'll just delete it here and I'll mark this only as chlorobenzene just to save your time, right? Instead of bromo you have chloro, so replace this. Till here it will be same and this will be changed because this Br2 will be Cl2, and here also it will be Cl, and here also it will be Cl, right? Everything else is same. Here it is chlorobenzene, you will convert this to disonium chloride, then add Cu2Cl2, or this is HCl, right? And that you will have the answer as chlorobenzene. Okay, quite simple. Next is aniline to iodobenzene. Now same, convert this aniline to Disonium chloride with the same method, that is at NaNO2HCl. After that, idobenzene means you have to react this with Ki, and directly disonium chloride will be converted to idobenzene. Another important reaction, right? Next is aniline to fluorobenzene. Now here you have aniline. To convert it into fluorobenzene, firstly convert it into again disonium chloride, then apply Bals-Schiemann reaction. This is Bals-Schiemann reaction. Okay, Bals-Schiemann reaction, and this will be directly converted to fluorobenzene. Isn't it, everybody? Isn't this amazing? Yes. 2-idopentane and pent-2-ene. So 2-idopentane, let's see, 1, 2, 3, 4, 5. 2-ido means here, and pent-2-ene, 1, 2, 3, 4, 5. And here you should have ene. Pent-2-ene, here you should have ene. You know what we can do? We need to do dehydrohalogenation is what I feel. If you have CH3 here, this is CH, this is CH2, CH2, CH3. And this will be CH, this is CH, H, this is CH2, CH3. So when you add here alcoholic QH, Z product will be formed, this will be eliminated, this is beta, this is beta, this is not chosen, this is chosen, because we need more alkyl substituted. If you choose this, you will have a double bond here. That is less alkyl substituted. We need more alkyl substituted. So alcoholic KOH will give you this particular alkene as the major product here. Right? Okay. Next is propene to 1-idopropene. Propene means 1, 2, 3. This is double bond. This is CH2. This is CH. Right? And this is CH3. Right? This is 1-ido. Now this is 1, 2, 3. 1-ido means here you should have ido. Here you should have iodine. This is CH2, this is CH2, this is CH3. Now see how you are going to do this. Now this is propene to 1-idopropene. So what you will do, actually, see, you need to break the pi bond and attach the iodine to more number of hydrogens. But in case of HI, even if you add peroxide, it does not give us anti-Markovnikov addition. So what I'll do, I'll add HBr in presence of peroxide. Now what will happen? This bond will break, pi bond will break, and hydrogen will be attached to less number, and iodine will be, bromine will be attached to more number of hydrogens. So anti-Markovnikov addition. Anti-Markovnikov means negative part to more number of hydrogens will be attached. Okay. Negative means poor. Poor will go to more hydrogen. That is anti. It's like in a good life, in a Markovnikov life, where everyone is saint, what should happen? Poor should go to the person, negative should go to poor one, right? The negative is actually poor. But here in this case, negative is actually with more. That means the one that is negative, that has a lot of money, and he is still very unhappy. Why? Because too much of money will not make them happy. So that way you can remember this, right? So this is, now I have to convert this bromine to iodine, and what I can see, can I apply Finkelstein reaction here? Finkelstein reaction, where I add NaI along with diacetone. That is a halogen exchange reaction, and bromine or chlorine is converted to iodine here. Isn't it? Yes. Then guys, next we have is, this is propane 1, 2, 3, and this is 2-bromopropane. So it is CH3, here it is CH, here it is CH3. This is converted to propane, and that to 1-bromo, that is this one. Now what I feel, that again you have to do, firstly add alcoholic QH. You firstly need to convert it to alkene. So take hydrogen from there. This will be CH3, CH double bond CH2. Now you add HBr, but in presence of peroxide. But in presence of peroxide. Okay, so that means pi bond will break, and this is negative, this is positive. This will attach to more number of hydrogens. That means here, right? So you have anti-Markovnikov addition again. Anti-Markovnikov addition, that means negative part to more number. Negative is going to more number in anti word. In anti word, negative is going to more number, right? So, prop1ene, 1-fluoropropane. So, it is prop1ene, that means this thing. 1-fluoropropane, that means this thing. I think by now, you should get an idea what to do. What I feel, firstly, I should add HBr here, right, in peroxide. Then I know that Br will be attached by anti-Markovnikov addition to more number of hydrogen, right? Now I can do Schwarz reaction. Schwarz reaction. Schwarz reaction says that you add AgF or any inorganic fluoride you add here. This bromine will be replaced by fluorine. Isn't it? Because HF you can't add peroxide. It's not possible only. So this way only you have to proceed. Okay. So now next reaction is you have 1-bromopropane. 1-bromo means here you have propane, and then this is being converted to 2-bromopropane. It's a very famous reaction. Very famous one. Okay. So here what you do, you have 1-bromopropane, and here what you will do, in the case of 1-bromopropane, what you can do here, see, firstly I think alcoholic KOH you should add. This will be eliminated, this will be eliminated. You will have CH2 double bond CH3. Okay. After that you will add here HBr without any peroxide, because then negative part will be attached to less number of hydrogen, that is here. So here it is less number of hydrogen, so negative part is attached here, and that's how you have the answer, right? Okay everybody, I want you guys to pause also and see if you're able to answer it or not. Next is but1ene to 1-iodobutane. So but1ene means on first position you have this thing, and this is CH2, no, it should be CH2 CH3. Okay, that is converted to butane. 1 2 3 4. 1-iodo means here you should have butane. I think we have done this before as well, right? So what you need to do, you need to add HBr in presence of peroxide. Negative part will be attached to more number of hydrogens, that is here. This is CH2 CH2 CH3. Now you do Finkelstein reaction. You add NaI, right? Then you add acetone, and the answer will be here. That is Finkelstein reaction. Okay. Now let's see the next one, that is chlorobenzene. So what you have here, chlorobenzene guys. This is chlorobenzene. You need to convert it to 2-chloroacetophenone. Acetophenone is COCH3, and second position you should have chloro. See, in this case, if you see, there is addition of one thing, that is COCH3. So, what you can do here, you can add CH3 COCl, right? And that will be in presence of anhydrous AlCl3. So this CH3CO positive electrophile, that will be attacked over here, and hence you will have, either you write it this way or any position you can attack it, it will be attacked here. So COCH3 and chloro, COCH3 and chloro, you will have your answer. That means this is nothing but this is Friedel-Crafts acylation. Acylation. Okay, done. Okay, next question here, propene. To propene 1O. Let's see what is propene. 1, 2, 3. Double bond. CH2. CH3. So here what you have? Propane 2ol. On the propane you have 2ol. Can you see that here? Oh my god, ma'am. What is that? How do I do that, ma'am? Alcohol. Yes. Let's see. See, if you say you want to actually add OH negative to less number of hydrogen here, so what I feel, what you should do, you can do two things here. You can do oxymercuration, demercuration. That means you can add mercuric acetate. That means ACO twice Hg, right? And NaBH4, you can do this. This gives you directly Markovnikov addition. Or you can also do acid catalyzed hydration. That also will give you the same answer. That means negative part to this part. Right? Okay. But here you have to firstly make carbocation and then rearrange it. Right? That, but answer will be same. Okay. Because rearrangement will not occur. Right? Okay. Then the question is propene to propane 1ol. 1, 2, 3 propene. That is CH2 double bond. This is CH3. Propane 1ol. That means here you have OH. Here you have CH2, CH2 and CH3. So what you have here, in this case, you need to add OH to this part. Anti-Markovnikov you need to do. That will be hydroboration oxidation. So this is hydroboration, that is, you can also say B2H6. Then oxidation is H2O2. It always gives you anti-Markovnikov product. That means OH negative to more number of hydrogens. Right, everybody? Got it? Tell me if that is clear to all of you or not. Okay, then there is ethyl chloride to ethanol. Ethyl chloride is CH3, CH2, Cl. Ethanol is what? CH3, CHO. How you can do it? Think, pause the video and think. Now, here are some questions that you need to think about. See, answered, pause and answered. If you're not still and done it, pause and then answer. Okay, now I'll start. I hope so you have answered it, right? Don't cheat. QH aqueous if I add here. I have done it in important reagent and naming reaction. I am repeating those, right? In a different way we are learning it. CH2 and replaced by OH because it is substitution. Now, if you do any mild oxidizing agent like PCC, PDC, I am using PCC, pyridinium chlorochromate, that will convert this part to aldehyde part, and hence you will have your answer here. Right? Done, everybody? Let's talk about next one, that is ethanol. CH3, CHO, 2 prop 2ol. Again, you have to think about this one. You have to think here. Think, everybody. Pause the video and do let me know if you're able to think it or not. Done. See, this is actually, whenever I need to increase the carbon atom, understand, whenever you need to increase the carbon atom in any carbonyl compound, use Grignard reagent. I need to add one CH3 here. So I will add CH3 MgBr here. right? If I use this negative positive, it will attack here, electrons will go, carbon with O negative, this is H, this is CH3, and this is another CH3 that has attached here. Now this will be MgBr, right? After hydrolysis, this will be CH3 and this will be H and this will be CH3, right? And here it will be converted to OH. That is the same thing that they are asking, right? Okay? Acha. Next is phenol to phenol. This you can easily answer, I know that. This all of you can answer. All of you can easily answer. I know that. I have faith on you. 2, 4 and 6. 2, 4 and 1, 2, 3, 4, 5, 6. Yes. 2, 4 and 6 tribromo. So directly what you will do? In phenol, add Br2 aqueous water. If you add Br2CS2, then mono product will be formed, right? Yes. What about this one? Methyl magnesium bromide CH3 MgBr into which part? Prop 2-ol and 2-methyl is there. This thing. Think. I'll tell you, same Grignard reagent with carbonyl reaction will take place. Think about this. Pause the video and think. Come on. Think about this. Done? Okay. Pause the video. Done. Now see. If I use CH3, C double bond O. Here I have 4 na. If I use 3 carbonyl, this is negative positive, it will attack here, this will shift here. So carbon, this will be O negative, MgBr positive. This will be 1 CH3 already, another CH3 already. 1 CH3 has the attack. Then you do hydrolysis. It will be converted to OH. Isn't it the same thing? Yes. Okay. Done. I think now you're getting confidence, right? Ethyl magnesium chloride, C2H5, or I'll just write it as CH3, CH2, MgCl. Propane 1-ol, CH3, propane 1-ol. Tell me what I need to do here. Everybody in the chat box, pause this and tell me what we need to do here. Right? Pause this and tell me what we need to do here. It is the same. I hope so you have done it because we are doing it, huh? So you have 2 carbon here, you need 3 carbon. So if I add something with only 1 carbon carbonyl, so that is formaldehyde, this is positive, this is negative. Negative will attack here. So this is carbon with electrons will shift here, that is O negative, this is MgBr, but here it is MgCl, so I will just write MgCl. Already this carbon had 2 hydrogens and one CH2CH3 group has attached. So now when you hydrolyze, this will become CH3, CH2 and this is CH2 and this will become OH. Isn't it the same thing? Yes, it is the same thing. Isn't it? How many we are left with? Just few, huh? Just very few we are left with. Let's do that. Almost 10 we are left with, 20 we have done. Phenol to orthohydroxybenzaldehyde. Phenol to ortho. On the ortho position, you have hydroxy and this is benzaldehyde. That means if I say this is CHO, over here you have OH. That clearly shows it's a Reimer-Tiemann reaction. It's a Reimer-Tiemann reaction. That clearly shows it's a Reimer-Tiemann reaction. That means what you need to do, just add here CHCl3 and KOH. This will be converted to, if you add NaOH, this will be converted to ONA and this will be CCl2. Then again you add KOH, aqueous, that will be converted to ONA and this is COH, OH. This will be eliminated, this will be eliminated, this will be converted to double bond OH, that is nothing but salicyl aldehyde. Okay? Done. For Cole's reaction, you have salicylic acid, right? And here if you use CCl4, then you will have salicylic acid. Okay? Yes. Then there is phenol to benzoquinone. So what is phenol? Phenol is this. Even aniline to benzoquinone is formed the same way. That is K2Cr2O7 or Na2Cr2O7 you can use here, right? That will be done. Usually we use Na2, so I'll use Na2. Okay? Benzoquinone. Right. Ethanol to propane to ol. Ethanol is CH3, CH2OH. Propane to ol is what? 1, 2, 3. Second you have ol. Now tell me how to do this. I need to increase one thing. So convert it into carbonyl and then do that. Convert it into carbonyl and then do that. Done? So what I'll do, I'll firstly oxidize this with PCC, mild oxidizing agent. This will be converted to this. After that, I'll add CH3 MgBr. This is positive, negative. Negative will attack here. Electrons will shift here. So you'll have CH3. This is C, this is OH, and this is H, and this will be CH3. And here what you will see, this is CHCH3. CHCH3. So that will be the answer that we have seen. Okay? Done? Acha, ethanol to but2-enol. This is very, very important. I'll show you why. Ethanol is CH3, CHO. You need to double the carbon here. That is 1, 2, 3, 4. Butane, 2-ene and 1-ol. That means this situation is done. Tell me if you can predict this or not. Very important, okay? This one is quite important. Like it is somewhat difficult to predict what will be done, right? But if you have done enough practice, then you will be sorted. So what you need to do here, see, here actually it's Aldol condensation. Okay, so how do you solve Aldol? Simple is, you have CH3, you have C double bond O, H. I'll give you firstly the trick. Open this and in the second part, open this one. Okay, now when you write it, connect this alpha carbonyl with the alpha with a double bond. So it is CH3, C, this is double bond CH, and this will be single bond CHO. Just complete the valency of carbon and this will be the answer. Now you will say, ma'am, tell us properly. So properly, if I tell you, how do you answer it? Properly it will be that firstly what will happen, there is a molecule of CH3's, wait a minute. So one base is going to attack and it is going to abstract the proton and electrons will shift here. So you will have CH2 negative and this will be CHO, right? Now this will attack on C double bond OH and this is CH3, right? Now this will attack here and the electrons will shift here. So what you will have, carbon with this is oxygen negative and this is hydrogen already. This is one CH3 already and here which is going to attack? CH2 CHO is going to attack, and this will be then converted to OH, that is nothing but CH3. Wait a minute, CH3CH. If I write it this way, CH3CHOH, this is actually CH3CHOH, or you can see OH here, and this is CH2CHO. Because this carbon has one hydrogen, one CH3, one OH, and one CH2OH. Right? Now alpha beta elimination will take place. Here OH will be eliminated, here H will be eliminated. Hence alpha beta unsaturated aldehyde will be formed. What is the trick to know this is done? If you have aldol, aldehyde and alcohol in one compound, or you have alpha beta unsaturated aldehyde, that means aldol condensation is done here. Okay. Acha. Next is acetylene to acetic acid. Yes, everybody. Acetylene to acetic acid, that is CH, this to acetic acid. Hoof. Now tell me. I think I know the answer. Okay, you tell me. Triple bond it is. If I somehow convert it into alcohol or something, I can do oxidation. Okay. So what I can do, if I do mercuric acidic hydration in the presence of mercuric, then what will happen? Pi bond will break, to one it will be H will be attached, to one OH will be attached. This is enol. Now tautomerization will take place here, right? This is 1, this is 2, this is 3. So this is CH, this double bond will shift here, right? This is C, this double bond will shift here, double bond O. There will be one hydrogen here and one hydrogen will shift here, that is CH3. Okay. Now you have CH3CHO. Now this part you have to oxidize. For that you can use any mild oxidizing agent here, and hence answer will be there. Right, everybody? Do let me know if that is clear to all of you or not. Right. Next is toluene to nitrobenzoic acid. Toluene to meta-nitro means here nitro will be there, this will be OH. See, meta-nitro, no. This is the ortho-para-directing. This is meta. So what I need to do, I firstly need to add KMNO4 for the oxidation. Any alkyl chain is converted to COH. Benzoic acid is formed. After that, you add concentrated H2SO4 plus HNO2, and hence NO2 positive electrophile will attack on the meta position, because this group is meta directing. Why? Because to a benzene, that group is attached which is pi bondedly connected to a more electronegative element. So it is meta directing, minus M effect is shown. Right. Next is bromobenzene to benzoic acid. Bromobenzene is this one. This is benzene of bromo, right? And this is converted to benzoic acid. For this, I need to add CH3. Tell me, how we can add CH3 here? Tell me, everybody. How we can add CH3 here? We need to increase the carbon atom. See, if I add Mg here, right, that I know this is little tough to understand. No, to understand it is easy, but to recall it is tough. Okay, so MgBr, this is, now if I have C double bond O, C double bond O, directly I can convert it into acid. How? This is partially positive, this is negative. Negative part will attack here, electrons will shift here. So benzene will be attacked to this, will attack on this carbon which has one O negative and one double bond O. This O negative is connected by MgBr positive, and after hydration this MgBr is connected to OH, and hence you have the formation of C double bond O OH, that is benzoic acid. Okay everybody, done? Okay, now you have aniline 2 okay, this is tribromo fluorobenzene. Okay, this thing, see, firstly let's do nitration, let's do bromination, Br2 aqueous. This will be converted to directly NH2, Br and Br. Tribromo we have. After this, what we need to do, tell me? Diazotization, NaNO2 and HCl, 0 to 5 degrees Celsius. This will be converted to N2Cl. This is Br, this is Br, this is Br, right? Then this part will be, we will use HBF4 here, that is Bals-Schiemann reaction. So N2Cl is converted to F, Bals-Schiemann reaction. Okay. So I think last two we are left with. One is ethanamine. We converted into ethanoic acid. Let's see how do we do that. Let's see everybody, ethanamine to ethanoic acid. Yes everybody, ethanamine to ethanoic acid. Yes everybody, do let me know how do we do that. Done? See here, I need to somehow convert it into either amide, then I can convert it into carboxylic acid. If I see to convert CH to NH2 to amide, tough task, right? That process I'll not follow. But if I convert it into, see this thing, HNO2 or NaNO2HCl, 0 to 5 degrees Celsius, that is, this thing is formed, CH3, CH2, N2Cl, disonium chloride salt, which is so unstable whenever this is alkyl part is the R part is alkyl and not aromatic. This is so unstable, it will be directly converted into CH3, CH2OH, and hence this with a very strong oxidizing agent like KMNO4 is directly converted to COH, and that's your answer. Okay, done. And last part is ethanoic acid. Ethanoic acid means CH3 C double bond O, or you can just directly write COOH to propanoic acid. Now see what I need to do. I need to increase one number here. I need to increase one number, guys. How do I increase that number? Tell me. I need to increase one number here. How I increase that number? See, directly with this I can't increase, but how I will do that? I hope so you have tried to do that. Now CH3COH, if I somehow convert it into carboxylic to carbonyl group, that is by reducing it to CHO, then I thought that let's add CH3MgBr. Now I think it must be more clear. This is negative, this is positive, it will attack here, and here it is actually C double bond O, so I'll just write it as C double bond OH. This will attack here, electrons will shift and this will become CH3. This is CO, this is negative, this is H here, and this is CH3. Okay, this is CH3. So now basically what you have here, you have CH, CH3, and this is MgBr, and this is positive. Now if I convert it, this will actually become, wait a minute, this is a long process. If I convert it, now it will become ethanol, and to that ethanol, I can't convert it into carboxylic acid just like that, right? But if that ethanol, one thing I can do, see, you can do other things also. What I am thinking, that I should now hydrolyze it and this will be converted to OH. Then I will dehydrate it. I'll add H2SO4, I'll dehydrate it and I'll convert it into CH3CH double bond CH2. Then I'll do hydroboration oxidation. Then I will convert it into anti-Markovnikov addition of OH. Now I have this. Now I will oxidize. Now I can use very strong oxidizing agent like KMNO4 as well to convert CH to OH to COH. Okay, done. It's not like what I am doing, you also have to follow the same pattern. Maybe there is some easy way out also, but now my brain is working like this only, so I'll do it like this. Right? Okay. Is that clear, everybody? Do let me know in the chat box if that is done. Do let me know in the chat box, guys, if that is done. Okay. So that's it for today. That was your organic conversions. And now tomorrow, today itself, you will have 30 top organic PYQs of your CBSE exam. And by tomorrow, we'll start with physical chemistry. So guys, see you all in the next class. Do let me know how you are liking these power pack, chota packet, bada dhamaka sessions. So see you all in the next video. Bye bye. Take care.